All right, complete the square, 12-2. Here we go. As always, I'll be talking fast. You can always pause it, rewind. This chapter was all about solving quadratics. Let's see, we've seen solving the ones like this from the previous class. Take the square root of both sides, plus or minus, so plus or minus 3. From quarter 2, remember we solved by factoring. Factoring asks the question, what two numbers multiply to 3 to add to 4? So what two numbers multiply to 3 that add to 4? That would be a 1 and a 3. 1 times 3 is 3. 1 plus 3 is 4. So we take the 1 and the 3, we put them inside of parentheses. We use the zero product property. We set each one of those parentheses, x plus 1 and x plus 3 equal to 0. This is all review. And then solve each one of those equations separately. Let's see. The first one, subtract 1, we get -1. The second one, subtract 3, we get -3. So that was solved by factoring. One more time. What two numbers multiply to 6, add to 5? It's not 1 and 6. 1 times 6 is 6, but 1 plus 6 is 7. But 2 and 3. 2 times 3 is 6, and 2 plus 3 is 5. So we take the 2 and the 3, we put them inside of parentheses, and we set each one of those parentheses equal to 0. That's called the zero product property. This is all review. You've done this before. So we subtract 2 from both sides on the first equation, x plus 2, subtract 2, we get -2, subtract 3 from the second one, and we get -3. So the two answers there are -3 and -2. This can work with negatives as well, too. It's the same process. Give me two numbers multiplied to -8 that add to +2. Well, it's not 1 and 8. -1 times 8 is -8, but those added together is 7. So it must be, in fact, 2 and 4. So let's see, a -2 and a +4. -2 times +4 is -8, and -2 plus 4 is, in fact, +2. All right, so we're going to use -2 and a +4 in our equation, set each one of those equal to 0, solve. You've done these hundreds of times, and we get -4 and 2. Okay, so that is a quick review, and no, we are not doing that tonight for homework. The but here is that not all quadratics are factorable. Here's one that isn't factorable. There aren't two numbers multiplied to -1 to add to 4. So it turns out before, the chapter that we did this on many chapters ago, we wrote unfactorable. In other words, we could not get to an answer. Today's class is, well, turns out there is a technique that will allow you to get to an answer. So what do? That's what today's class is on. How do you solve unfactorable quadratics? All right. So it's a big, tough class. And by the way, this is the second time you've heard this. All right, stay with me. All right, it is a procedure. And remember, this is the slide that I have lots of stuff going on here. I'm just trying to show you the patterns. If your quadratic trinomial can look like any one of these three, these are special ones that I purposely chose. If they look like this, what number times itself is 9 that adds to 6? Well, that is 3. What number time, and there's 2 of them, so I can write it like that. That looks like the previous night's homework. What number times itself is 16 adds to 8, is 4. Well, there's 2 of them. It can be written like that. What number times itself is 25 that adds to 10? That is 5. So it can be written like this. Now, I chose 3 specific ones. And then the next thing I ask you to do is notice between those 2 colors right there, there is a pattern. And there is a pattern. As long as the equation at the top there looks like ax squared plus bx plus c equal to 0, as long as it looks like that, then a pattern emerges. So if you start with a perfect square trinomial, which is that top line right there, well, in its factored form, I'm asking you to compare that number or those numbers with these numbers right here. And notice that each one of those numbers is half of the original number. So in other words, in factored form, if it's a perfect square trinomial, then the factored form will just be taking b and divided by 2. Look at what's highlighted and look at the arrows. Each time we're simply dividing by 2. Well, that's great as long as it's a perfect square trinomial. There's a second pattern here. And the second pattern here is the unfactored form. That's the top line right there. In the unfactored form, those 3 right there, if I look at what I just highlighted in blue, there's another relationship. B is 6, B is 8, B is 10. And the relationship between B and C is the fact that C is B divided by 2 squared. 6 divided by 2 squared is 9. 8 divided by 2 squared is 16. 10 divided by 2 squared is 25. Now, this only works if you start with a perfect square trinomial. So great, you get these great two patterns right here. All right. And I ask you to copy everything in yellow down. And that's supposed to be on the top of the page when you do every one of these procedures that you're about to do. The factored form and the unfactored form. So, and by the way, you can always pause the video. So this is the magic. So to solve an unfactorable trinomial quadratic, right? There is no number that multiplies to -1 that adds to 4. We would initially call this infactorable. The magic makes it factorable, right? Here is what we do. So this is the procedure. Step number 1 is you move C. Well, what's C? C is -1, so move it to the other side. Add 1 to both sides, and you would get that. Step number 2 is you make a new C. The new C, we go back to our patterns, and the pattern says that the new C is B divided by 2 squared. So which number is B? B is 4. So we're supposed to take 4 divided by 2. 4 divided by 2 is 2. Square it. 2 squared is 4, right? I am not writing what B is. I'm taking B divided by 2 and I'm squaring it. So my new C is 4. We're going to add 4 to both sides of the equation. To the left side and to the right side, I'm adding 4. That's my new C value. Now on the right side, 1 plus 4 is 5. On the left side, it's factorable now. We made it. That's the trick. We made it factorable. And luckily for us, the pattern of factoring is sitting right there. It simply says take B and divide it by 2. 4 divided by 2 is 2. So I'm going to write x plus b. B is 4. Divided by 2 is 2. So I write x plus 2 squared equals 5. And now it looks like last night's homework, or the pre 12.1. We take the square root of both sides. I get a plus or minus root 5. It's an ugly number, but it is what it is. We take our calculator. The square root of 5 is about 2.24. So we get a negative 2.24. We get I'm rounding, a positive 2.24. And then we move the 2 over to the other side. So we subtract 2 from both sides. And we're going to get a negative 4.24. I'm subtracting 2. And a 0.24. I will simply do a bunch of these. You simply need to follow the patterns. This is called complete the square. All right, here's another one. All right, step number 1, move C. C is -16. Add 16 to both sides. Step number 2, make the new C. The new C is sitting right there. B divided by 2 squared. B is 6. 6 divided by 2 is 3. 3 squared is 9. So I'm going to add B divided by 2 is 6. 6 or the 3. B divided by 2 is 3. 3 squared is 9. So I'm going to add 9 to both sides. Add 9 to the left. Add 9 to the right. 16 plus 9 is 25. The left side is now factorable, so we can factor it. And the answer is sitting right there. It says take the old B and divide it by 2. 6 divided by 2 is 3. So it turns into always x plus or minus B divided by 2 squared. Take the square root of both sides. Hey, we're lucky this time. The square root of 25 is 5. So we get a plus or minus 5. This will break down into 2 equations. X plus 3 is equal to -5, and x plus 3 is equal to +5. Subtract 3 from both sides, and we get -8 and 2. Example after example after example. Practice makes perfect. Step 1, move your C. Add 20. Step 2, make your new C. Your new C is B divided by 2 squared. -8 divided by 2 is -4. -4 squared is 16. Add 16 to the left and to the right. There's it added to the left, and there it's added to the right. 20 plus 16 is 36. Factor the left side. The left side factor form is sitting right there. It says x plus b divided by 2. B is -8. -8 divided by 2 is -4. Take the square root of both sides. Square root of 36 is 6, so I get plus or minus 6. So I get my 2 equations. X minus 4 is equal to -6, and x minus 4 is equal to +6. Add 4 to both sides. So we're going to get -2 and a 10. Play the video over and over and over. When you're doing your homework, play the video while you're doing the homework. Each step is the same. All right, there are some really messed up ones. We'll do one and call it a day. So when B is odd, things go badly very quickly. B is odd here. All right, so get rid of the C. Add 144 to both sides. Make a new C. This is where it goes badly. Why? Because C is not even. When we divide an even number by 2, we get a nice friendly number. When we divide an odd number by 2, we get a fraction. We're going to get 7 over 2, and 7 over 2 squared is 49 over 4. 7 divided by 2 is 7 over 2. Square 7, 49. Square 2, 4. So the new C is 49/4, which we need to add to both sides. On the left side, well, we're going to factor. On the right side, I got to get a common denominator. The common denominator is 4. So multiply 144 times 4, add that to 49, and we get 625 over 4. Factor the left side. The left side factor is b divided by 2, 7 over 2. Take the square root of both sides, and you should be panic. But wait a minute, 625 is a perfect square. So is 4. 625 is 25, or the square root of 625 is 25, and the square root of 4 is 2. So we get 25 over 2, plus or minus. We write our two equations, very small, but you can see it. And then we subtract 7 over 2 from both sides. 7 over negative 25 minus 7 is negative 32. Divided by 2 is negative 16. 25 minus 7 is 18 over 2, and that's 9. There you go. We're going to stop the video right here. I don't want to do too many of these more challenging ones. I want you to focus on the even ones where b is even. Get that process down first when b is even, and then try an odd one. The odd ones are always going to be ugly like this. So that is your class on solving by completing the square. If you have any questions, just ask.